Right, in today's video, we're going to learn how to factorize quadratic functions in different ways. So let's do a recap. Quadratic functions are in the form y equals to ax squared plus bx plus c, and a not equals to 0. Do you know why is it a is not equals to 0? To answer the questions, let's suppose a is equals to 0. So if a is equals to 0, what do you end up with? Yes, you end up with y equals to bx plus c. And would that be a quadratic function anymore? Oh no, that is a linear function, right? So therefore, for quadratic functions to be valid, a cannot be 0. And if a is not equal to 0, a can take two different forms. A can be a positive value or a can be a negative value. So in this example, we're going to do with a being a positive value. Let's see what happens. All right, so how would the curve look like when you have a positive values for a? So we've mentioned earlier, it would be a U-shaped curve. So it could be in this form. So if you look at this curve, can you see that the curve is shifted more towards the right-hand side? And if you observe carefully, we will have a minimum point there. Right. And how do we find this minimum point? Okay, so we just simply let me use a different color. Simply let x minus h equals to 0. And you have x equals to h. Right. If x minus h is equal to 0, what will you end up with for the y coordinate? You would have a multiplied with 0 squared minus k. And that will give you the y coordinates to be negative k. So therefore, your minimum point will be h comma negative k. So one example would be right, this will be one example where your minimum point is 2, negative 3. All right, let's look at another different kind of representation where the curve is shifted more towards the left-hand side. Right, so in this case here, you would see that your x coordinate of your turning point will be negative h. For the y coordinates, because it's below the x-axis, it's negative k. So one example would be, right, where your minimum point here is negative 2, negative 3. All right, so if you look at the curve that we've drawn, you will see that this curve has actually two real and distinct roots. Where are the roots? Let me erase this. So the roots are indicated here. The roots are your solutions to the equations when you let y equals to 0. So the roots are your x-intercept values. So therefore, there's another way to factorize these quadratic functions, and that is called the intercept. You're factorizing using the x-intercepts. So here, your P and Q are your x-intercepts. So I'm going to give an example. So it could be something like this. This is negative 2. This is 3. Right. So your curve will be x plus 2, x minus 3. All right. So these are the different ways of how you can actually factorize a quadratic functions where a is more than 0 and where you can have two real and distinct roots. All right, so what happens if your curve is entirely above the x-axis? Right, so for this kind of curve, how are you going to factorize it? Yes, you can still factorize it using the completing the square method. Right, so in this case here, then your minimum point will be h comma k, right, where the values, your y coordinates, it's more than 0 because it's entirely above the x-axis, but your x coordinates could be a positive or a negative values depending on how the shape of the curve will look like. So if your curve is in this way, then your x coordinate, the turning point, will be a positive 2. Then your y coordinate will be a positive 3. Or your curve could goes this way. So in this case here, your x coordinate will be negative 2, but your y coordinate will always be a positive value. It will be a value that's more than 0. Right, so there's a questions for you to ponder. And what is the questions? Hang on, let me erase all this. The questions to ponder is, right, in this type of curve, you cannot express the quadratic function in the x-intercepts factorized form. Why is that so? So to answer the questions, ask yourself, what does x-intercept means to you? X-intercept means it's an intersection point on the x-axis. When the curve cuts the x-axis, the 2 points are your x-intercepts. Or rather, the x-intercepts are actually the solutions to the curve when y equals to 0. So if you go back and look at this curve here, do you see any x-intercept there? If there's no x-intercept, then are you able to represent it in the x-intercepts form? So what kind of solutions or what kind of roots will this curve represent? If the curve is entirely above the x-axis, there's no x-intercept, that means there's no real solutions, right? So it means there's no real roots. So therefore, you can't express it in the form, in x-intercepts form. So you can only express it in this form, or the completing the square method format. All right, let's go to put quadratic functions aside for a while, and we're going to have some fun time. Yeah, it's jokes time. I think I'm not going to say wahahaha. Okay, I don't know if it's going to be funny or not, but anyway, wahahaha. Right, the first one. There's a fine line between a numerator and a denominator. Do you get it? Doesn't matter if you don't get it, because only a fraction of people will get this joke. Right, never mind. Let's try another one, okay? Don't give up. Just that when you do math, and if you don't get the answer, don't give up. Just keep doing it. Second one. What do dentists call the x-rays? I think you should be able to answer these questions. This question definitely is easier than solving some mathematical sums. The answer is, it's called toothpicks. Do you believe it? It's called toothpicks. All right, never mind. I think I failed in telling jokes. All right, I think we get back to quadratic functions. I think that is, I'll explain it better. Right, so now we come to the last part, where a is more than 0. How would the curve look like? So if you observe the curves that I have on the screen, right, you can see that the curve actually touches the x-axis. Right, touches the x-axis. So what does it mean? What would the value of the y-coordinate be? If the curve touches the x-axis, what will be the y-coordinates be? Yes, the y-coordinate will be 0. So how would be the factorized form looks like? Yes, so it can be, if you look at the one on the left-hand side, in this case here, if you let, okay, wait, hang on, I'm going to change it to green. If you let x minus h equals to 0, then x equals to h. So therefore, your minimum point will be h comma 0. Okay, it's h comma 0 because it touches the x-axis. Right, and for the one on the right-hand side, if you let x plus h equals to 0, x will be negative h. So therefore, your minimum point will be negative h comma 0. Right, so the next question is that, can you represent this kind of curves in x-intercept form? Yes, of course you can, because if you look at the diagram, right, we actually have the x-intercept here. It's a repeated roots. This kind of curve has actually two real and repeated roots. So you can actually represent it in the x-intercept form as a bracket x minus h squared, or y equals to a. Okay, wait. Let me explain. Hang on. I can represent it this way. Y equals to a bracket x minus, let's let the x, let's let the, what do you call that, the x-intercept be p. So that will be a bracket x minus p times another x minus p, right? Because we're talking about the same roots. It's a real and repeated roots. So you can stack this up to get a bracket x minus p squared. And what do you observe? Yeah, it's exactly in the same format as what we have done earlier on. Okay, so likewise with this also, we can write it as a bracket x plus p multiplied with another x plus p. Stack it up. You will have x plus p to the power of 2, which is the same as what we have here. Okay, so this one will cover the different kind of ways you can factorize the quadratic functions where a is more than 0. You can do it for a less than 0, right? You will still get the same, what do you call it? The concepts are still the same, right? Except now that if a is less than 0, then you're dealing with the n-shaped curve. You will not be dealing with the minimum point. Here you'll be dealing with maximum point. But remember, the concepts that you learn here will be applicable, will be this. You can apply it, to when a is the negative value.